So we have seen the outer diameter DO, that is tube diameter, as 0.495 meter. Okay, because we have found U2 by equating W actual to that is Cp T02 minus T012 mu into U2 square. This will give you U2 and U2 will indirectly give you outer diameter 0.495. So rise in total temperature, it was asked T02 minus T01. Okay, in the numerical, that's why it is written as 194.59 Kelvin as one of the answer. Now next, the most important thing which is asked in the numerical. Okay, if you see, calculate the tip speed, diameter and rise in total temperature, that we have found. Tip speed is also found, diameter is also found. Also determine the external diameter of the eye, for which the internal diameter is 12 centimeter and axial velocity at inlet is 150. Okay, internal diameter of the eye. Okay, so it is inlet condition. So if you see in this diagram, this is the tip diameter. Okay, outer diameter DO. This is the impeller. Okay, this is outlet and this is inlet. So for this inlet, this is the inlet. Okay, through this annular space, the fluid is flowing or air is flowing. So this is the D1 is the diameter. Okay, inlet diameter, and D2 is the outlet diameter for this annular space. So the cross sectional area, which is pi by 4 D2 square minus D1 square, that will be the area for this annular space. Okay, so are you getting? So to find this area, you should know what is the specific volume. Okay, because mass flow rate is equal to rho AV. Okay, and rho is 1 by specific volume. So AV into AV upon specific volume, or A1 into C1 upon specific volume. So that's why you should know what is V1. To find V1, you should know P1 V1 is equal to MRT1. So from that you can get. So for that you should know P1. So we know the from this diagram, that is P01 and P1 is having relation. P01 upon P1 is equal to T01 upon T1 raised to gamma upon gamma minus 1, which is equal to 288 upon 277.29 raised to gamma upon gamma minus 1. So P01 is given as 1 bar in the numerical. So P1 will come less than P01. So it is coming 0.876 bar. Once you know P1, you know P1 V1 is equal to RT1. So R is 300, T1 is 277.29. Okay, this is static temperature, static pressure. So this will give you the specific volume 0.9496 meter cube per kilogram. Mass flow rate now, this mass flow rate is nothing but this annular area multiplied by velocity V1, which is 150 meter per second given in the numerical, upon V1, the specific volume 0.9496. So mass flow rate is 8 kilogram per second. So you can find A1 from this pi by 4 into D2 square minus D1 square, this annular area, that is equal to 5.0464 into 10 raised to minus 2 meter square. So this, if you equate, D1 is given as 0.12 meter. So if you put the value of D1 here, A1 here, you can get the value of D2 as 0.2863 meter. So this is the answer. So simple numericals are there. Only you have to make practice for more number of numericals on centrifugal compressor. So this is the end of numericals for centrifugal compressor. Let us immediately move towards the last part of this unit, that is surging and choking, and some axial compressor, that is only remaining. So let us quickly finish it. What do you mean by surging and what do you mean by choking? These are the most important phenomenon occurring in the pump. Okay, so before that we will see, before surging, choking we'll see. Okay, so if you see in this diagram, let us see the overview. This one is a choking line. Okay, choking line is nothing but basically this is first, this graph is on y-axis there is a pressure ratio and on x-axis there is a mass flow rate. This is a pressure ratio, there is a mass flow rate. Okay, so this is the head developed and this is the discharge. Okay, head versus discharge, that is the curve. Okay, and the nature is like this, that we know from centrifugal pump also, the nature is like this. So mass flow rate, choke, we know choking means maximum mass flow rate. Choke condition, we have heard the word choke. Okay, pipeline is choke, means what? The mass flow rate has become maximum in that pipeline. Okay, further you can't supply the fluid because of choking happening in the pipeline. So you can go for maximum mass flow rate, that is called as a choking condition. So this is shown by the dotted line at point E. And what do you mean by surge? Surge is nothing but this is maximum mass flow rate condition and this is the minimum mass flow rate condition. So through this range only the pump will operate or the compressor will operate. That is called as a safe zone of operation. So on the left side it is taken care by surge line, and on the right side it is taken care by choking line. So let us see what do you mean by choking and what do you mean by surging. So choking, let the compressor be run with completely closed delivery valve. Initially the delivery valve is closed. Okay. So what will happen when the delivery valve is closed? Then the pressure will be, that is discharge is 0. So pressure is at point A. Okay, because the impeller will run though the delivery valve is closed. So pressure ratio will be at point A. Further, as you go on increasing the discharge, the pressure will go on increasing. Okay, you follow this line. Okay, and accordingly you have to describe. So as you increase the pressure discharge, the pressure will go on increasing. So there is no problem from A, B, C. Okay, as you increase the discharge, the pressure will go on increasing. But after point C, there is a discharge, a decrease in head. Why? Because of their losses in compressor we have seen. Okay, so because of friction, eddy formation, this pressure goes on decreasing as you increase the discharge further. So C, D, E, F, it is the nature of the curve. Okay, after maximum efficiency is reached, or after maximum pressure is reached. So D to E to F. So F is the point where you are getting maximum mass flow rate, but at the same time F is the point where you are getting zero pressure ratio, or equal pressure ratio. That is, pressure ratio is 1. So inlet and outlet pressure are equal. So it is not our condition, that we don't want equal pressure ratio. So we want the pressure to be high. So there is a point E, okay, which is in practical limits. So practically you can go up to point E, that is maximum mass flow rate, and not up to point F, because theoretically you can't go, okay, up to point F. So practically it is possible only for E point. So E point is called as a choking line or choking point. Okay, so E shall indicate the maximum mass flow rate practically possible. This maximum mass flow rate is choked mass flow. Okay, so that is called as the dotted line towards the right is in the figure is known as choke line. What do you mean by surging? Now let us see surging. Okay, so left hand side dotted line is called as a surging line. Now this understanding of surging is important. Choking is easy to understand, maximum mass flow rate. But what about the surging? Surging is nothing but the vibration of the pump or the compressor takes place because of the to and fro motion of the fluid, okay, inside the pump on the left hand side, okay, where the mass flow rate is less. Now let us say we are opening the delivery valve, okay, from A to C. Okay, while opening the delivery valve, the pressure increases and the discharge also increases from A, B, C. So there is normal operation up to point C, no problem. Okay, so while opening the valve, the curve is followed as it is, because upstream pressure is more than the downstream pressure and the flow takes place in normal way. But when you are closing the valve, suppose you are closing the valve and the discharge is decreasing, okay, from C to A. Okay, so at the closing of the valve there is a problem. Okay, so when you are closing the valve, so the pressure is falling from B to B2. Okay, that is mass flow rate is decreasing while closing the valve, and when it is falling from B to B2, okay, the pressure upstream, that is PB2, is less than PB, and because of that there is a reversal of the flow. Okay, so the PB pressure, it is greater than PB2, that's why the pressure flows back. Okay, instead it should go up. The flow rate takes place in the reverse direction. So this reversal of the flow happens because of the decrement of the upstream pressure, okay, in case of closing of the delivery valve. So closing of the delivery valve causes the reversal of the flow, and this is called as a surging. So this reversal of flow causes pulsation to the compressor, and noise and vibration jerks are felt during this transition phase. This phenomenon is called as a surging. There is one more phenomenon. Okay, so because of surging and choking, your compressor is run between these two limits. The dotted line towards left is shown as a surge line. There is one more phenomenon that is called as stalling. Okay, apart from surging and choking. Stalling refers to the boundary layer separation. We have seen the boundary layer separation in fluid mechanics. So the stalling is nothing but the instability in the flow during the flow separation from that surface. If the flow is separated from the surface, then naturally there will be wake formation or the eddy formation, and because of that there will be the reversal of the flow take place. Okay, and the reverse phenomenon is not desirable. So flow separation is not desirable, that we have seen. Flow separation is not desirable. Flow should be attached to the surface. So if the flow separates from the surface, then it is called as a stalling. So that you remember. Okay, surging, choking and stalling. Now let us quickly move towards the last topic, that is the axial flow compressor. Axial flow compressor is same to that of the centrifugal compressor. Its function is also to increase the pressure. But there is one most important difference is that in axial flow compressors you are getting low pressure increment than the centrifugal compressor. Okay, but the number of stages, are more in case of axial flow compressor. That is the advantage of axial flow compressor. While in case of centrifugal compressor, it is very difficult to obtain staging in case of centrifugal compressor. So let us see the difference between axial flow compressor and centrifugal flow compressor also. But before that, axial flow compressors have the fixed blades and moving blades mounted along the axis of the compressor. Okay, this is a fixed blade. Okay, we have seen in steam turbine also such type of construction. Okay, so it is reverse of the steam turbine. Axial flow compressor is the reverse of steam turbine. Okay, so it has primarily two components, rotor and casing. The rotor has blades mounted on it, which are moving blades. Rotor has moving blades and casing has fixed blades. Okay, that already we have seen. So this is the stages. Okay, one fixed blade and one moving blade, that is the stage. Now what is the difference between centrifugal compressor and axial flow compressor? Let us see quickly the difference. Centrifugal compressors generally have stage pressure ratio of around 5. Okay, one stage produces pressure ratio of 5, while axial flow compressor produces stage pressure ratio of 1.5 only. So you are getting less pressure ratio across a stage. But it have radial flow inside the axial entry of the fluid. This has the axial inlet and axial exit. Maximum pressure up to 400 bar can be obtained from multi-staging. Maximum pressure of 10 bar can be obtained from multi-staging. Centrifugal compressors have good part load efficiency and wide operating range between surging and choking limits. But axial flow compressors have poor part load efficiency and narrow operating range. So operating range of centrifugal compressor is more. That's why it is most suitably used. Centrifugal compressors have small starting torque requirement. See, the torque requirement is also small. Axial flow compressors require higher torque. Okay, that's why these are more feasible. Due to large frontal area, these are well suited for land application. The area required for this is very large for centrifugal compressor. But it is because of small frontal area required for axial flow compressor, they are used in jet engines or aviation applications. These have simple construction and comparatively cheap. These have complex construction and costly. Okay, because jet applications. They have poor isentropic efficiency. Power required is more for centrifugal compressor. They have better isentropic efficiency and power required is less in axial compressor. Efficiency versus speed characteristics for centrifugal compressor is flat. Efficiency versus speed characteristic is somewhat bell-shaped. Okay. But the last point is centrifugal compressor's performance does not alter with any kind of deposition on blade surface, but axial compressor performance deteriorates with any kind of deposition on the blade surface. So more care you have to take for axial flow compressors, because these are very you can say their application is very typical application, jet engines. Okay, so they should be designed very carefully. So but centrifugal compressor, it is rough and tough, you can use anywhere. So likewise we have seen the difference between centrifugal compressor and axial flow compressor. So I hope you have understood what do you mean by the centrifugal compressor, okay, and axial flow compressor. The parameters in axial flow compressor are also same as that of centrifugal compressor. Their velocity diagram, HS diagram, it is also near about same. We have not gone in detail. I hope you will study it, okay, through books, because there are no numericals in axial flow compressor. So that's why we have not taken axial flow compressor in detail. We have seen partly the theory part, but you can read the theory from book for axial flow compressor. Most important part is the centrifugal compressor. We have seen the numericals on centrifugal compressor as well as theory of centrifugal compressor. So in centrifugal compressor, you remember, okay, the construction and working as well as TS diagram, okay, isentropic efficiency based on static condition and total condition. What do you mean by slip factor? What do you mean by work input factor? What do you mean by the pressure coefficient, isentropic efficiency and the relation between them? Okay, so that much is required in centrifugal compressor to solve the numericals. Okay, so you practice more numericals on centrifugal compressor and solve all the numericals, okay, on centrifugal compressor. So I hope This is the end of syllabus of